Pay attention. So, one of the things we're going to talk about today is the periodic table and how it's organized. We've been leading up to this. The discovery of atoms. It's a concept that you can take some things and divide it up into the smallest pieces till you can't divide it anymore. That's literally what the word atom means. It means undividable. And so we're going to talk about a bunch of people today. But the arrangement of the elements into rows in order of their atomic number, which therefore also has an increasing mass. And then we've noticed there's some groupings and stuff we're going to talk about that has to do with the arrangement of the atoms and their structures themselves. So in 1860, Dmitri Mendeleev developed an approach to organizing the elements while playing a game of solitaire. Basically, you sort the cards in a very specific way according to suit. So what he did is he kind of constructed this thing by groups. And as you see there's group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Our modern periodic table is structured in a similar way. Why is it that way? Well, the final arrangement was similar to a winning arrangement in solitaire, except that the columns were organized by the properties instead of the suits. Within a column, the masses increase from top to bottom. And his chart was the periodic table. A periodic table is an arrangement of elements and columns based on the set of properties that repeat from row to row. So the atoms in group 1 have a very specific reason that puts them in group 1, and so does group 2 and all the groups. So at the time that he made his table, many elements have not been discovered. He placed the elements where their properties fit, and there were several gaps in the table. He tried his best to explain the gaps, but he was confident that the gaps in his table would be filled by new elements. In other words, human beings hadn't quite discovered all these elements yet. And so he used the properties of the elements located in the blank spaces in his table to predict the properties of undiscovered elements. In other words, the way that he grouped them, and I'll just let you in on the secret, it's the outermost ring, how many electrons they have in the outermost ring. Group 1 has 1 electron. Group 2 has 2 electrons. Group 8 has 8 electrons. All right. So some scientists didn't accept these predictions, and others used these predictions to help them to search to find undiscovered elements. So what evidence helped verify the usefulness of this table? Well, the close match between his predictions and the actual properties of new elements showed how useful his periodic table would be. He named missing elements after elements in the same group, and he gave them a name like aluminum to be a missing element, one space below aluminum. So aluminum. And he predicted that it would be a soft metal. He predicted that it would have a low melting point and have a density of around 5.9 grams per cubic centimeter. And then later in 1875, a French chemist discovered a new element. He named the element gallium in honor of France. Latin name for France is Gallia. Gallium was a soft metal. It had a melting point of 29.7 and the density of 5.91. So he wasn't that far off, okay? Heat from a person's hand could melt gallium, and in some traffic signals there is a tiny light emitting diode or a LED. And now everybody has them in their bedrooms, the color LEDs, that contain this compound in it. So scientists use the periodic table to explain the chemical behavior of the different groups of elements. the properties of gallium were remarkably similar to the predicted properties of this eka-aluminum. So scientists concluded that gallium and aluminum are the same element. So this continued to go on. All right. So the periodic table, from its beginning, had different things, but the elements with similar properties were grouped in which? The same row, the same column, diagonal lines, or pairs of twos. What do you guys think? That's where I can tell if you guys are paying attention to me or not. In the same column, okay? Maybe you guys aren't awake yet. I see some kids shaking their head. Which element did Mendeleev correctly predict the properties even before it was discovered? Gallium, right? So he was just basing it on the chemical properties. It probably doesn't make sense now, but it has to do with the number of protons and the number of electrons and how many electrons are in the outer ring. So he said, look, I don't know what goes in this space, but it should do these things, okay? And that's it.